Welcome to our exploration of super-Earths and their mysterious oceans. Could these giant planets harbor alien life? Let's dive in and find out. Out there in the vast cosmic ocean far beyond our solar system, lie planets that make Earth look like a tiny blue marble. We're talking about super-Earths, massive worlds up to 10 times heavier than our own. What makes these planets so intriguing is the possibility of vast, deep oceans on their surface. Oceans that could potentially be teeming with extraterrestrial life. In this video, we'll journey to these alien worlds, explore the science behind detecting water on distant planets, and delve into the tantalizing possibility of finding life as we don't know it. Buckle up, space explorers, because things are about to get cosmic. So, what exactly are super-Earths? Well, they're not just bigger versions of our planet. They're a whole new class of planets that we don't have in our solar system. These planets are larger than Earth, but smaller than Neptune, putting them in a kind of Goldilocks zone of planetary sizes. But here's where things get really interesting. Super-Earths come in a variety of flavors. Some are rocky like Earth, but much, much bigger. Imagine mountains that dwarf Mount Everest and canyons that would make the Grand Canyon look like a ditch. Then there are water worlds, planets completely covered in oceans, hundreds, maybe even thousands of miles deep. Can you imagine the kind of creatures that might lurk in those depths? And let's not forget about the thick atmosphere super-Earths. These planets are shrouded in dense atmospheres, creating extreme pressure and heat on their surfaces. Not exactly hospitable for us, but maybe perfect for some forms of life. But here's the kicker. Many of these super-Earths orbit their stars within what we call the habitable zone. That's the sweet spot where temperatures are just right for liquid water to exist on the surface. And as we all know, where there's water, there's the potential for life. Now you might be wondering, how do we even know if there's water on these distant super-Earths? It's a fascinating question, especially considering the vast distances involved. After all, they're light years away. The sheer scale of the universe can make it seem impossible to study these distant worlds in detail. Well, that's where things get really clever. Astronomers have developed some ingenious methods for studying the atmospheres of exoplanets, planets that orbit other stars. These methods allow us to gather information about these distant worlds without ever having to leave our own. One way is through a technique called spectroscopy. Imagine light passing through a prism. It splits into a rainbow of colors, right? This simple principle is the foundation of a powerful tool in astronomy. Well, starlight passing through a planet's atmosphere works the same way. By analyzing the specific colors of light that are absorbed or transmitted, we can identify the chemical fingerprints of different molecules in the atmosphere, including water vapor. This method allows us to detect even trace amounts of water. Another way to find water is by studying a planet's density. We can determine a planet's mass and size by observing its gravitational pull on its host star and how much light it blocks out during a transit. This data helps us infer the planet's composition. A low-density planet with a large radius is likely to be composed of lighter elements like hydrogen and helium, or, you guessed it, water. This information is crucial for understanding the planet's potential to support life. And then there's the reflected light method. Just like our oceans reflect sunlight, giving Earth its blue hue, water on other planets can also reflect light from their host star. This reflection can tell us a lot about the planet's surface and atmosphere. By analyzing this reflected light, we can look for specific signatures that indicate the presence of vast oceans. This method is particularly exciting because it can give us direct evidence of liquid water. One incredible example is the super-Earth K218b, located about 124 light-years away. This planet has captured the imagination of scientists and the public alike. Using these techniques, scientists have detected water vapor in its atmosphere, making it a prime candidate for further study. The discovery of water vapor on K218b opens up exciting possibilities for future exploration and the search for life beyond our solar system. Okay, so we've found water on a super-Earth. This discovery is monumental because water is one of the essential ingredients for life as we know it. But what does this really mean for the possibility of life existing on these distant worlds? Does that mean there's life swimming around out there? The presence of water certainly raises our hopes, but it's just one piece of a much larger puzzle. Well, it's not quite that simple. Scientists have to consider a multitude of factors before concluding that a planet can support life. Life, as we know it, needs more than just water. It requires a complex mix of chemical elements such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, which are the building blocks of life. It needs a source of energy, a stable environment, and the right chemical building blocks. On Earth, the sun provides the energy that fuels most life forms through the process of photosynthesis. On Earth, life thrives in a delicate balance of conditions. From the deepest oceans to the highest mountains, life has adapted to a wide range of environments. But super-Earths can be vastly different. These planets, which are larger than Earth but smaller than Neptune, can have a variety of characteristics that make them unique. Their intense gravity, extreme pressures, and potential lack of a solid surface present unique challenges for life as we know it. The gravity on a super-Earth could be much stronger than on Earth, making it difficult for life forms to move around. For instance, the pressure at the bottom of a super-Earth's ocean could be immense, crushing anything we could imagine. This would make it difficult for life forms similar to those on Earth to survive. The lack of sunlight penetrating those depths might also hinder the development of photosynthesis, which is how most life on Earth gets its energy. Without sunlight, life would need to find alternative energy sources. But hey, who says life has to be like what we find here on Earth? The universe is vast and full of surprises. Life on other planets could be very different from what we're used to. What if life on these planets has found a way to thrive in conditions we consider extreme? On Earth, we have extremophiles, organisms that live in environments that would be deadly to most other life forms. Perhaps there are creatures that feed off geothermal vents, using chemosynthesis instead of photosynthesis. These organisms convert chemicals from the Earth's interior into energy, allowing them to survive in the dark depths of the ocean. Maybe life on these planets is silicon-based instead of carbon-based. Silicon, like carbon, can form complex molecules, and some scientists speculate that it could be the basis for life in environments very different from Earth. The possibilities are truly mind-boggling. The more we learn about the universe, the more we realize how little we know. Despite the challenges, there are some promising candidates in our search for life. These planets have conditions that might support life, even if it's very different from what we know. We've already mentioned K2-18b with its confirmed water vapor. This planet is located in the habitable zone of its star, where temperatures could allow liquid water to exist. Then there's Kepler-22b, a super-Earth located about 600 light-years away, which orbits comfortably within its star's habitable zone. This means it could have the right conditions for liquid water and potentially life. And let's not forget TOI 1452b, a planet recently discovered by NASA's TESS mission, which is also thought to be a water world with the potential for life. Each of these discoveries brings us one step closer to answering the age-old question, are we alone in the universe? The search for life beyond Earth is just heating up. With every passing year, our understanding of the cosmos deepens, and our curiosity grows stronger. With each new discovery, we're getting closer to answering that age-old question, are we alone? The data we gather from distant worlds is like pieces of a grand cosmic puzzle, slowly revealing the bigger picture. Thankfully, we have some powerful tools in our arsenal. These advanced instruments are the eyes through which we peer into the vast unknown, capturing light from stars and planets millions of light-years away. The James Webb Space Telescope, the most powerful telescope ever built, is already revolutionizing our understanding of exoplanet atmospheres. Its capabilities far exceed those of its predecessors, allowing us to see the universe in ways we never thought possible. Its advanced instruments will allow us to study the chemical composition of super-Earth atmospheres in unprecedented detail, searching for those telltale signs of life, also known as biosignatures. These biosignatures could be the key to unlocking the mysteries of life beyond our planet. And if that's not exciting enough, there are even more ambitious missions on the horizon. These future missions aim to push the boundaries of our knowledge and capabilities, taking us closer to the stars than ever before. The Large Ultraviolet Optical Infrared Surveyor, LUVOIR, a proposed space telescope even larger than the James Webb, could directly image exoplanets and their atmospheres. This would be a monumental leap forward in our quest to find habitable worlds. Imagine actually seeing the continents and oceans of a super-Earth with our own eyes. Such images would not only be scientifically invaluable but also profoundly inspiring, igniting the imaginations of people around the world. But perhaps the most daring idea of all is sending interstellar probes to these distant worlds. These probes would be our robotic explorers, venturing into the unknown to gather data and send it back to Earth. While still in the realm of science fiction, advancements in propulsion technology could one day make this a reality. Concepts like light sails and nuclear propulsion are being explored, bringing us closer to interstellar travel. Imagine a probe diving into the ocean of a super-Earth, sending back data about its composition and searching for signs of life. This would be an unprecedented achievement, providing direct evidence of the conditions on these distant worlds. Now that's what I call exploration. The excitement and joy of discovering something truly new and groundbreaking is what drives scientists and explorers alike. The discovery of extraterrestrial life, especially intelligent life, would be the most profound event in human history. It would challenge our understanding of biology, evolution, and our place in the universe. It would change everything we thought we knew about our place in the cosmos. Our perspective on life, existence, and the universe would be forever altered. And who knows, maybe one day we'll even shake hands or tentacles with our cosmic neighbors. The future of exploring super-Earth oceans is bright, and the possibilities are endless. Super-Earths might be home to massive, deep oceans, perhaps filled with alien marine life. If we can detect liquid water and biosignatures, we may be on the verge of the biggest discovery in human history. The quest to find life beyond Earth is one of the most exciting and profound endeavors of our time. With each new discovery, we're peeling back another layer of the cosmic onion, revealing the universe's awe-inspiring secrets. Would you like to explore a specific super-Earth in more detail? Let us know in the comments below.